We're going to look at one more example of using U-substitution to evaluate an integral. So the example is to evaluate the integral of 1 divided by e to the x plus 1 dx. We're going to see a couple of different methods of how to accomplish this. Here's method number 1. I call this method adding a 0. So we're going to look at the integral again of 1 divided by e to the x plus 1 dx, and we're going to add a 0 in the numerator, and that form of 0 would be e to the x minus e to the x. So we just add e to the x, subtract e to the x in the numerator. This doesn't change anything. It is still the same integral. And then we separate the numerator into 1 plus e to the x, and then divided by 1 plus e to the x, and then minus the integral of the other part of the numerator, which is e to the x, over the denominator 1 plus e to the x. We recognize the first integral as the integral of 1, and then the second integral is the integral of e to the x divided by 1 plus e to the x. So of course the first integral is x, and then minus the integral of e to the x over 1 plus e to the x. And this we do by using U-substitution. So I'm going to do this in this box. The integral of e to the x over 1 plus e to the x. We let u equal to the denominator 1 plus e to the x. Du is equal to e to the x dx. And this integral is integral of 1 over u du, which is natural log of u. We don't need absolute value since u is equal to 1 plus e to the x. It's always positive. So the second integral equals to natural log of 1 plus e to the x. And hence, the integral of 1 over 1 plus e to the x, which we cannot do using U-substitution directly, by adding a 0 to the numerator, we get the solution. It's equal to x minus natural log of 1 plus e to the x plus c. Method 2, I call that method multiplying by 1. So we take the original integral, 1 divided by 1 plus e to the x, and write it as the integral of 1 divided by 1 plus e to the x times 1. Again, no changes made to the integral. And the form of 1 that we want to take is e to the negative x over e to the negative x. So if we use this instead of 1, here's what happens. The numerator is 1 times e to the negative x, which is e to the negative x. The denominator is 1 times e to the negative x, and then e to the x times e to the negative x is 1. And then once we transform the integral into this equivalent form, we let u equal to e to the negative x plus 1. Du equals minus e to the negative x dx, or minus du equals e to the negative x dx. And hence, the integral of 1 divided by 1 plus e to the x, you saw that when we multiplied by 1, we transform it to integral of e to the negative x over 1 plus e to the negative x. Using the U-substitution, we end up with negative du over u, which is minus 1, the integral of 1 over u du, and that's minus natural log of u plus c. Once again, u is positive, so absolute value is not needed. And that gives us negative natural log of 1 plus e to the negative x plus c, which we can write as negative natural log of e to the x over e to the x plus 1 over e to the x plus c, and that's equal to minus natural log of 1 plus e to the x, or e to the x plus 1 over e to the x plus c, which is negative natural log of the numerator, 1 plus e to the x, or e to the x plus 1, minus a minus plus natural log of the denominator, which is natural log of e to the x, but natural log of e to the x is x, so we end up with the same answer as when we use method number 1, namely x minus natural log of 1 plus e to the x plus c.